main objective of this program is to explain about quicksort algorithm. Essentially, here we may take one element of the array, which we may call it as a pivot element. Of course, that element can be any element, but normally we take first element, and then we'll try to find out, or we try to move the array elements such a way that all the elements less than this pivot element will come to one side, that is left half, and more than this pivot element to the right half. And then we will insert this element in the middle, rather I say in between these two things. Once we fix up this pivot element location, it will not change at all. That is, rather we are finding out the location information about this element in the final sorted array. Obviously, in the sorted array, if we assume that ascending order, all the elements less than this should come one side and greater than this should come other side. So, we don't want here at this junction to sort the elements which are less than this, which are greater than this. No. We are interested to find out its location. So, this we achieve first. This is the essence. This is normally done by traversing left to right till we find out an element whose value is greater than this pivot element. Similarly, we will traverse from the other side, the right hand side of the array, and find out the element whose value is less than this pivot element. We will try to exchange these two things. If the first element whose value is greater than pivot element is I, and less than when you come from the other side, that is j, if I less than j, then we exchange these two, otherwise will come out. And then we will put the pivot element at the location I, if required, by moving the elements which are before I by one element. This is the entire essence. So once we fix up the location of the pivot element, the problem becomes, that is, it's more like a divide and conquer procedure. So the pivot element got fixed, and all the remaining elements before that, they are not sorted, and above that, they are not sorted. We require to sort this half and that half. Again, this is repeated. Again, we apply this quick sorting algorithm on this half and also on the right half. This is a divide and conquer example. So the algorithm for this is given in the following slides, and a demo is also included. The program for this quick sorting algorithm is given in this slide. It contains two functions, a swap function. We have to send the array and the indexes of the two elements whose values we want to exchange. The function exchanges the elements values. And the second function, quicksort, it requires an array as an argument and beginning index of the array element and the last element index of the array elements which we wanted to sort. So here usually we take the first element, that is the start element itself is the pivot element, and as mentioned earlier we traverse the array such that from left to right, such that we will find out an element whose value is greater than a pivot element. So when we come out from that while loop, first while loop, the I value indicates the index of the element whose value is greater than pivot element. Similarly, we have written another while loop which starts from the last element of the array, that is the end, that is index end, that we are taking it as a k, and we'll try to come towards the 0th element, that is the first element of the array, and try to find out the element whose value is less than the pivot element. So when this while loop condition becomes false, when we come out from the while loop, k value indicates the element of the index of the element whose value is less than the pivot element. If k greater than I, the element values will be exchanged. Ith element, kth element values of this array will be exchanged. So, and then we sort the quicksort function recursively. So the problem becomes two partitions. Those elements, that is, rather I say, of course we wanted to fix, we have got now I. What is the value of I? That is the index where the pivot element is going to be in the final sorted array. That's the one we fixed it. Then we are still required to sort the elements before this pivot element, after this pivot element. For that, again, we will be calling quicksort function by sending the array and the start element, that is the starting element index, and k minus 1. And then we may require to send the other half information also. Let us try to know how really this algorithm works with some sample simulation. Just for the sake of demonstrations, we are taking an array with the values 3, 1, 4, 5, 9, 2, 6, 8, 7, total 9 elements. Of course, first element index is 0, the last element index is 8, C language style. So, for the purpose of explanation, we take red indicates the swapping, blue indicates comparison. Any special situation will be demonstrated with green. Initially, from the main, we assume that for this function quicksort, the array having these numbers are sent, and start value is sent as 0, and end value is sent as 8. Thus, in the function, I value becomes 0, k value becomes 8. And the pivot element is taken as 3. You can see 3 is in blue. the pivot element become value is 3. Now the while loop is supposed to traverse from left to right and find out the element whose value is greater than 3. Thus, when I value became 1, the element value is 1. Is it greater than 3? No. Thus, I value will be incremented by 1. Thus, when I value becomes 2, its value, element value is 4, that is greater than 3. Thus, the while loop gets terminated. So, currently I value becomes 2. Now, the second while loop starts executing. Initial value of k is 8. So, kth element value is 7. We are looking for an element whose value is less than the pivot element 3. So, while this value is 7, thus the while loop continues. Then the next element value, k value will be reduced by 1. Thus k value becomes 7. That element is 8. 8, is it less than 3? No. Thus while loop control again continues. Then next element is 6. Is it less than 3? No. Now when k value becomes 5, the element value is 2. It is less than pivot element 3. Thus the control stops here. Now the currently k value is 5. And this element, that is k greater than I, yes, this condition is true. Thus the elements 2 and 4 gets exchanged. After this, the first while loop continues again to find out the element whose value is greater than the pivot element 3. I value 2 only. So it's already 2. Is it greater than 3? No. Thus the while loop goes to next element, that is 5. 5 is greater than 3? Yes. So thus now the first while loop breaks there. I value is 3 now. Similarly, the second while loop again starts from the previous point where it has stopped, that is fifth element. Currently we have what value is there? It is 4 is there. So 4, is it less than 3? No. Thus control comes to that element before that, that is 9. Is it less than 3? No. It comes to 5. Is it less than 3? No. So when k value becomes 2, the value is 2. So thus the control while loop becomes false. So thus k value becomes 2. Now when k value is 2, whereas I value is 3. So if condition becomes false, thus will come out from the if condition. Now especially we require some extra thing has to be done now. So the problem we have to demonstrate to show that if I place the pivot element before 5, then all the elements before 5, they are one type, they are maybe incidentally in this example 1, 2 they are sorted. However, above 3, maybe if I place 3 before 5, what are the remaining elements after 3, 5, 9, 4, 6, 8, 7? They are not sorted. So now we have to apply sorting on those partition of this array. So that's how we are going to do in the following next slides. The quicksort function is again called. This time we are sending the starting and ending indexes as 0 and 1. And in this partition, 2 will be taken as the pivot element. Since this partition contains only two elements, when the left movement while loop, maybe first while loop when it starts executing, when I value becomes 1 itself, it becomes false, indicating that this element, one element, which is available in, out of these two elements, pivot element 1 and the remaining element 1. So all the elements are less than the pivot element, which indicates that so pivot element can be kept after this 1 such a way that that portion gets sorted. Now, after fixing the pivot element 3, the left portion got sorted, and now we are left with the right partition. Thus, the quicksort function will be called again. For that, 3 and 8, their starting index and final index, that will be sent as arguments. That is, we are interested to sort that portion of the array. For that also, the same operation will be carried out. Here also, the first element will be taken as the pivot element. That is, 5 is taken as pivot element. So, as usual, when the first while loop runs to find out the element whose value is, we are interested to find out the element whose value is, rather I say, greater than 5. So, we will start from left to right. Into evidently 9. That becomes the element whose value is greater than 9. Similarly, the next while loop, it will start from the ending and traverses to find out the element whose value is less than 5. So, that becomes 4. So, incidentally, I value, that is 4, and k value, that is 5. K greater than I? Yes. Thus, they gets exchanged. When both the while loops, when they continued further, I value becomes 5 and k value becomes 4. As k is not greater than I, the control comes out, and then 5 and 4, they gets exchanged. And then the leftover, the problem again becomes two subpartitions. Incidentally, for 5, once we fix up 5, its location, left hand side contains only one element, that is 4. There is no need of sorting that one, it itself is sorted. And the right hand side contains 4 elements that they are supposed to be sorted now. Thus, the quicksort is called, and this time the starting element index is 5 and the ending element index is 8 will be sent. Anytime when you enter in that partition, first element will be taken as the pivot element. Here this time 9 will be taken as the pivot element. It will be fixed. When this function calls proceeds, a quicksort call is made with the starting element index and ending index as 5 and 7. So this time the fifth element is 7. That will be fixed. Previously the element value 9 is fixed. Now 7 will be taken as a pivot element. Its location is fixed. Finally, the array got sorted. In general, the array is having elements in random fashion. Then the quicksort algorithm gives better results compared to the array having elements in already ordered fashion. That is, if the array contains elements in order, either ascending or descending, then it shows worst case behavior. You can verify the following figure. Moreover, if one selects the pivot element as median of the array elements or partition, then it gives us solution quickly. That is, it requires less number of recursive calls. However, selecting median may take more time. So basically we are talking that somehow in a magic fashion, if we can select median as a pivot element always, then the resultant solution requires less time. The order of the complexity of this algorithm is n log n. We will be explaining about this one in our lecture notes.